In this video, we will discuss about Graham's law of diffusion or effusion. Let's have overview of this law. Gas molecules are in a state of constant random motion, so they intermix with each other forming homogeneous mixture. Diffusion is a process by which two or more gases intermix each other to form a homogeneous mixture independent of gravitation. So diffusion is a process in which gas molecules move from an area of higher concentration towards an area of lower concentration. Let's have example of this process. If hydrogen sulfide H2S is released at one corner of room, its smell can be detected at another corner after some time. This is because of diffusion. Again, the term effusion, which is a process in which gas under pressure escape out a fine hole. Example is leaking out of a gas from cylinder or air from a punctured tire, etc. However, the process of effusion is always followed by the process of diffusion. Let's have statement of Graham's law of diffusion. This law can be stated as: under similar conditions of temperature and pressure, the rates of diffusion of gases are inversely proportional to the square root of their densities. Mathematically, this law can be represented as R is inversely related to the square root of density, where R is rate of diffusion, D is density of gas. Let's have two gases having R1 and R2 be the rates of diffusion of two gases. Their densities be D1 and D2 respectively. Then according to Graham's law of diffusion, R1 would be equal to K square root 1 over D1 and R2 is equal to K into square root 1 over D2, where K is proportionality constant. Combining 2 and 3, we get as R1 over R2 is equal to square root D2 over D1. Equation 4 is the mathematical expression of Graham's law of diffusion. We know that molecular weight is twice the vapor density. So, molecular weight is equal to 2 into vapor density. Therefore, M is equal to 2D. M is the molecular mass. D is vapor density or simple density. Or D is equal to M over 2. Using equation or relation 5, the Graham's law equation 4 becomes as R1 over R2 is equal to square root M2 over 2 divided by M1 over 2, or simply square root of M2 over M1. Equation 6 is another form of Graham's law of diffusion. Again, rate of diffusion is defined as the volume of gas diffused per unit time. So, rate of diffusion is equal to volume of the gas diffused divided by time of diffusion. Mathematically, this can be written as R is equal to V over T. Let T1 and T2 be the time taken by gas to diffuse V ml of two different gases. Then R1 over R2 is equal to V over T1 divided by V over T2 is equal to square root of M2 divided by square root of M1. From above equation 7, we can say that the time taken for diffusion of equal volumes of gas is directly proportional to the square roots of their molecular weights or densities. Now we come towards importance of Graham's law of diffusion. Graham's law finds its importance in number 1, it helps in the separation of gases having different densities. Number 2, it helps in the separation of isotopes of certain elements. Number 3, it helps to determine the density or molar mass of an unknown gas by comparing its rate of diffusion with a known gas. Carbon dioxide in atmosphere is heavier than oxygen and nitrogen gas present, but it does not form the lower layer of atmosphere. Why? This is all because of Graham's law of diffusion. Gases possess the property of diffusion, which is independent of force of gravitation. Due to diffusion, the gases mixed into each other and remain almost uniformly distributed in atmosphere regardless of heaviness or molar mass. That's all from today's video.